So when we divide polynomials, we use a method called synthetic division, and that's what I'm going to be teaching you today. So synthetic division, well, why do we divide a polynomial in the first place? So we have this x plus 4, and we want to see if x plus 4 is a factor of this polynomial, and that's why we divide. So how do we know if x plus 4 is a factor? Because if we divide and we get a remainder of 0, then we know this is a factor. So let's go do some synthetic division, I guess you could call it. So over here is where we write the polynomial or the thing we're dividing, but you only focus on the coefficients, which is the good part about it. So we have a 2 in our first one, we have a 7, we have a -6, and then we have a -8. And on this side we write this. So x plus 4, we don't write a 4 over here. We actually write a -4 because this is going to be equal to 0. So -4. And here is where the process starts. It's very simple. So always for the first term always you bring down the first number, I guess you could call it. So we bring down to 2, and then we multiply it with -4. So then we get -8. But then we add after this, so it'd be -1, and then multiply, we get 4, and then add, and then multiply, and then add. Yeah, you get the thing. So -6 over 4, -6 plus 4 is going to equal -2, and then -2 multiplied by -4 equals 8. So if we do -8 plus 8, we get a remainder of 0. So that tells us, using this synthetic division process, that x plus 4 is a factor of this quadratic, not quadratic, this polynomial. Let's do this example. So we have x to the 4th plus 2x squared plus 5 divided by 2. So same thing as before. Let's write our 2 over here, and we write our 1. But then we notice that there is no x to the 3rd or an x. So we don't ignore them. We have to write a placeholder, which is going to be 0. So you're always going to need to write a placeholder. If so, there's an x to the 4th. If there is no x to the 3rd, you need to write a placeholder, or else your problem is not going to be right. So then we have 2. And then we have another placeholder for the 1. Then we have a 5. So we end up having 4, 3, 2, 1, and then, so that's correct. Then we have our plus 2. Bring down the first term, we get 1. You multiply, we get 2. You bring down, add, we get 2. 4. Add, we get 6. Multiply, we get 12. And then we get 12, and then we get 24. So we notice that our remainder is not 0, meaning x minus 2 is not a factor of this polynomial. So for our remainder, we end up getting 29. And we can still write this as a polynomial. So how we're going to write this is we're going to do 1 x to the 4th, actually x to the 3rd, x to the 3rd, x to the 2nd, x, and the plus, x to the 3rd plus 2x squared plus 6x plus 12, and then with our remainder we do plus 29 over x minus 2, which is the thing we were dividing with this. So this is how we write the polynomial. And let's go ahead and write this polynomial as well, because I forgot to do that. We notice that we have an x to the 3rd. We have an x to the 3rd. So I'm going to end up doing 2x to the squared minus x minus 2. And we don't need to write, what we did over here, because the remainder is 0. So that is how you divide a polynomial using synthetic division. There is another method called long division, which it's not really easier. It's a bit harder and it's a bit more tricky. We'll go over that. Link in the description if you want to see long division. And when can't you do synthetic division? Because synthetic division won't really apply to, you can't really do synthetic division always. You can't do synthetic division if the x, usually all the things would be x, it would be a linear term. But what if we had a quadratic term like this, or a term like this? Well, that's when we would use long division. So you can't really do synthetic division if it's not a linear term.